Various process equipments like pumps, fans, blowers, winders, unwinders, coilers, conveyors, etc. use electric motors as their prime movers. Torque speed characteristics are most important considerations in such drive systems. In some process requirements, the torque and speed requirements from a motor is variable at different times. Many applications demand such variations as part of process requirements. For instance, a typical yarn manufacturing involves motors to draw the yarns at different speeds to meet desired specifications. These are dynamic requirements, wherein the speed of the motor is varied as per process needs. Along with the speed requirements, the desired torque demand also has to be met to avoid any breakage and process interruption. Similarly, centrifugal machines like pumps or blowers driven by AC motors are required to deliver variable outputs under different process requirements. Speed control of the motor results in variations in the energy consumed by the motor. Also, the power consumed by the motor is proportional to the cube of the speed of the motor. This would mean that a 20% reduction in the motor speed would result in 80% power reduction, which is very significant. Controlling any process parameters like pressure or flow by varying the speed is more effective than employing any physical means like a damper to control these parameters for this very reason.
Variable voltage, variable frequency control. With variable voltage, variable frequency operation, any combination of voltage and frequency can be used to supply the motor with the condition that operation should remain within the limits of rated voltage and frequency. VVVF is provided to achieve the required VF control for smooth running of the motor. Usually, motors with VVVF type control are used in open loop where the applications need variable speed but tolerate inaccuracies due to slip. First, voltage boosting. At low frequencies, typically less than about 1/4 of the base frequency, the stator supply voltage can be boosted to maintain the magnetism voltage and hence maintain the rated flux in the machine. 2. Constant volts per Hertz operation. Many commercially available drives have the option for some form of constant volts per Hertz operation with voltage boosting at lower frequencies. Using this approach, it is possible to accelerate a motor from zero speed to rated speed smoothly and without the high inrush currents normally associated with induction machine starting. 3. Operating regions. 4. Tau omega c square. A variable voltage variable frequency drive is capable of operating over a wide speed range. There are 3 distinct operating modes illustrated in the diagram here. Below base speed. This is the constant torque region where VF control can be applied with low frequency voltage boosting. Constant power. Above base frequency, there is a region where slip speed can be increased without exceeding rated currents and without coming too close to pull-out torque. Voltage must remain at the rated value, so this is a field weakening region. Field weakening. Constant slip speed. As the field is weakened, a point is reached where slip speed cannot be increased any further.
Here are some key aspects that you may consider while considering the role VFD plays in a larger system. Safe torque-off function method. VFD as safety instrumented system and monitoring the system. safe torque-off STO functional method. STO function is a high-integrity pulse disablement unit which isolates power of firing pulses to semiconductor devices, that is IGBTs, in the drive. Inside a VFD module, the switching signals are conveyed from the complex control circuit to the IGBTs by opto-isolators. In the safe torque-off arrangement, the power supply to the opto-isolators is provided by a fail-safe circuit from the enable input. If you wish to engage your organization in such learning, get in touch with us and we shall be happy to support you. For viewing more such demonstrations and to get such customized e-learning courses for your team, please do get in touch with us.